Just got a bunch of new vices from Eric at Orange Vice. Super excited. Pulled out my Norseman with a damn steel blade. Started cutting into it. I always make this mistake whenever I get a package from Eric. He staples all the packages and then covers the staples with tape. So I'm always like banging the knife into staples. Bad idea. But let's see what he sent. I gotta like feel for staples first. Huh? There's staples there too. I should just cut the sides off. Yeah, it's really heavy actually. Nice touch. Oh, it's so bad. There was a side staple. I mean, I appreciate the staples and doing good packaging. My knife does not. All right, what do we got here? Okay. I don't think there's any staples. Oh God, it's really heavy. New vices just came in. There's more over there. One thing I love is that they're now drilling and tapping holes right here, because if you remember a couple weeks ago, months ago, we actually drilled and tapped our old vices to put a stopper in there so that this thing doesn't slide out.
Orange should have done from the start.
Yep. So now there's a drilled and tap hole, so we can just put on a little fence on there. Love it. He was telling me that he got his own black oxide setup in-house, so they're doing these steel parts or cast iron parts with their own black oxide coating, which is pretty nice. They were raw before, I guess. Cool. Staple, staple, staple. Don't do that. Oh, that's worse than I expected. You can actually see the blade like bended.
Like this?
I actually bent the blade. He needs a sticker that says caution staples. Oh, this one's lighter. So my good friend Amish, who lives in Vancouver, British Columbia, you know, I've been wanting to make these new fixtures for a long time, but we don't have the time to do it ourselves. Amish offered to do it. I'm happy to pay him. He's a good friend of mine. Oh my gosh, these things are so amazing. All right, whatever machine he has, I want one. Wow. They're basically exactly like the one that I made for myself, except better because it's got all of our tweaks built right into it, instead of hacking away and like changing the new one or the old one. But Amish did a super good job. They look amazing. I can't wait to dig into them and try them out. So we got 4 of these guys, and 2 new orange vices. So we're gonna load up the table and go. I love it. So what we're doing right now is we made a bunch of old fixtures to go on the old pallet that we did. I changed a few things on Amish's new pallets. So we've got 3 old center pallets. We got to move this hole down to here. So Angelo created a program where it's the two tools are going to come in and they're going to create little holes here and here, and we're going to pop out the 3 pallets that we have. That will allow us to mount the old pallets on the old fixture and the new fixture. That's step 1.
All right, good to go?
Yeah. Okay, the next thing we're going to do to these other 2 fixtures that we've had for quite a while is same thing we did to this fixture. This is our production one. We've been using this. So we drill and tap 2 holes on the side and on this side, which we attach the pocket clip to. So what this allows us to do is imagine the fixture's mounted like this. You've got a clip on the side like that. We used to machine the pocket clips like this, where we'd have to take an end mill, we'd come in, we'd mill away all this material, mill the contour, take a ball mill and contour the whole thing. It took quite a while. And then I was like, wait a minute, idea. What if we put it on the side of the fixture and then take an end mill like this and literally just do this? It takes less than a minute. It takes very little effort. The tool is super strong. I dig it deep all the way down. The side of the flutes I never use on this tool. I pretty much only use the tip, so it's like a free tool. So this works awesome. The tool lasts forever. I love it. Super efficient method for production. So now we're just drilling these fixtures on the side, because when I made them I didn't have this theory yet. So we're just going to do that using these 2 tools right here. So we got a parabolic drill bit and a spiral flute cutting tap. So rigid tapping is something I don't do very often, but it always terrifies the heck out of me. Have you ever done it much?
A bit of it, yeah.
Yeah?
Yep.
So I mean, for those of you who don't know, I mean, this is a spiral flute tap, so this makes a threaded hole, right? So the way this works in rigid tapping is the spindle has to rotate as it's going downward, like you're threading in the screw. But it has to be exactly the same and retract exactly the same with no deviation. Otherwise you're going to break the tap, or if your cutting load is too high, what's it going to do? It's going to like...
That tap might get stuck in your part and then that's going to retract. And you better hope that you don't have any other tools coming in there to perform a chamfer.
Where the tap is still there?
Or a counterbore or any secondary operations.
Jeez.
So I've seen it happen once. Rigid tapping, like you can't really control your pitch. You can't control your thread very much, so it's good for like fixturing. We're mass production.
Yeah.
And then on the threads we make on the actual parts, we're using a thread mill and we're dialing in the pitch, and but for tooling, this is the way to go. It's faster, it's quick.
Yep.
It's just a little...
It's kind of amazing how fast it goes. It's literally just whoop, done. But I'm always like, every time it happens.
Yep, just got to make sure everything's tight and strong and rigid. And
it's actually very underwhelming to watch, but scary.
Yeah.
All right, put it in, touch it off. So right now, in the background, Angelo is finding the position of the fixture in X, Y, and Z. So he's doing Z first, and he types in a special string of code, which we've got right up here. And then it just goes, the probe comes in and goes boop, and then he's going to do one for Y and one for X, and he put it in the vise and mounted it up against the side. So when we put in the next one, we can just hot swap it, put it in, and hit go, and we won't have to zero it again. What I like to do in a simulation is if you scroll up here to the top, all the way to the top, you can light bulb the whole thing. So it keeps the stock, but it hides the model. And it's transparent, so you can see your tool going through. So just hit play and see what happens. Spot, spot, tap, 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 tap. Rigid, chamfer, that's what's going on. Looks good to me.
Did one side, we probed here, we're going to flip it and keep the same setup because the accuracy we need for these holes isn't super critical at this stage. So from there, we're going to be okay with about a 10th out true position, which we should be able to hit, maintain, like doing it this way with the setup. There's some pins installed in this one. This one's already assembled. So we're going to use the 1, 2, 3 block to space away from the pins. Keep it square, and without much pressure, we shouldn't do any damage to the part. So we don't need a high amount of rigidity in this operation because we're just drilling and tapping 2 holes. If we were doing something that was going to be putting a bit more load into the part, we'd be trying to constrain the 12 planes of movement. Right now, we're not going to see much, so the way we have it right now in this setup will be more than enough for what we're going to do. No point in getting overcomplicated. So that's our first op right now. We're essentially making half the clamp, and then we're going to flip it over and put in some soft jaws. So I've already checked the hole size to ensure that they're good. We're not going to see amendment for true position or do anything. I'm just going to actually fit it up to the fixture itself to ensure that this is going to load up and be workable and doesn't have too much play, and it's exactly what we want. So from there, that's going to be then go into soft jaws, where we're going to do the other side and essentially make our clamps like that. So right now I'm stacking them up for their first op. These are done and checked. We're basically cutting half the clamp through. We go past the center line, so we have to be careful for warping. Anytime you cut past the center line of your material, you can essentially start to allow the part to bow. We're not seeing any bowing now, so it's pretty good. We're cutting slowly. It's not too aggressive, and we're not taking out too much material. We're still leaving a lot of beef there so that it's not going to flex too much. But yeah, it works, and we've got a bunch to do. Got to go through. We're going to be doing, we already did half the first op on clamp number 1. Now we're doing clamp number 2. There's 8 of them. Then we move to clamp number 3, and then finally clamp number 4 will be on this side. So we're just doing first op on all of them with the hard jaws, and then we're going to start setting up our soft jaws, picking up our new G offsets, doing each one individually, and then bang through the other side. So about halfway through the day, we should be able to get these done pretty soon. So simple as that. Want to make sure that there's no burrs on our raw material as I'm loading them up. So I just quickly skim these with a file, make sure nothing's going to be sitting wonky or not allowing us to provide enough clamping force, which could cause the part to move a little bit. So go from there. So since this is our first op, the position isn't super critical because we're essentially making our part that we're going to be locating in soft jaws later, but we still want to make sure we're not way off. So I just generally butt it up there and then get it nice and tight there, or not tight, but just soft. Hit it with a dead blow. A little bit more pressure, not too much. Don't need a lot of pressure, but you want to make sure you have uniform clamping force around and that there's nothing causing, like if I have a chip in here and this is going to wobble a little bit, as soon as I start, putting much load into the part with my tools, you could run the risk of pulling the part out, and that is the last thing you want. We're gripping onto about 100 thou material here, which is adequate, and we're going to be coming up 10 thou from this face for cutting. So we've proven that already. All the clearances are good. So let's make another part.
So we have made really good progress on the clamps for the handles and the blades for the fixtures. They take a long time, but we're making really good progress. We did make 2 kind of bloopers here. So one shifted, it's like a zigzag. It's supposed to look like that, but it ended up looking like that. Oops. Slight fixture offset, like a 1/4 inch off. So it just made the thing like a zigzag. Oh well, no big deal. It worked fine. And then this one I had the wrong edge selected in Fusion. So it decided to pocket away all this material when actually it's supposed to look like that. But again, no big deal. Toss it, we have extra material. So toss those 2 aside, these 2 are good. The goal is to be able to make enough clamps to run 4 fixtures at a time, which is a lot of clamping. So far we've only been able to make enough clamps for 2 fixtures, which took the spare time within 2 entire days to make this happen. And so we have these ones here that are now half done, and we'll just kind of leave those waiting for next time for when we have more time. If we can get up to 2 fixtures ready to go, 2 fixtures on the machine right now, it'll let me prove out my code, which is my next task, and then we'll be able to run 2 at a time, which will be a huge improvement over 1. And then we'll work our way up to 4 after that. So I got some serious coding to do on the computer, just to figure out how they're going to loop and back up and rewind and move over and probe and do all that. I'm looking forward to it. I've been crunching it in my head for a couple weeks now. Looking forward to seeing it working. Hey guys, thanks for watching part 1 of this video. In the next part, we're going to finish up. We're going to get the code running. We're going to explain to you guys how it works. We're going to show the fixtures being loaded and put into the machine and explain kind of how the probing routines work in the machine. So I'm looking forward to that. Stay tuned. Catch you next time. Later. Bye-bye.